Good morning, everyone, and welcome to Graniterock's Product Knowledge Seminar. My name is Jackie Serrano, and I will be your host today. For today's seminar, we have a very special guest who is an expert in the world of natural stone products. We hope you are all as excited and ready to learn as we are. For everyone's information, we will be recording this session to grant replay access to those who are unable to join our live event today. Before we get started, we ask everyone to please keep yourselves muted and camera turned off. The chat is open, so we encourage questions or comments throughout the meeting. If you happen to have a question, please add it to the chat section and we will try to answer them as soon as possible. I will now hand it off to Vaughn. Go ahead, Vaughn.
Thank you very much, Jackie. And thanks everybody for showing up today. I'm really excited to teach you guys how we make our natural limestone thin veneer. To give you a little bit of background story on AAA Natural Stone before we get going, we have actually been in the mining business for over 35 years in several different locations. But one of the locations we're going to show you today is one of the pits that we actually resource a large majority of our blocks from that we are currently processing through. It's a brand new pit. So you're going to get to see what it looks like from the time we uncover the land down to building stone and each ledge as we process through. With that being said, I'd like to go ahead and start you off on our first little video here. This is what we're going to consider to be virgin land. Clearing the land, one of the things you want to look for in the right type of property for processing limestone is number one, rock that's close to the surface. As you're going to see here, and I'm going to try to, I hope you can see my little pointer here. You can see the line that I'm showing you, this pile of dirt. This is the fresh land, and the land that we've cleared down below it, you're going to have about 3 to 4 feet. If we only have to clear 3 to 4 feet to get to good usable building stone, that's going to be a great piece of land to work with. Because then some parts of this land, if you notice how nice and flat, almost like a football field, this whole area is. Now that's something that's really hard to find, to be quite honest with you. A lot of land is rolling. It has hills. It has drainage going through it, natural drainage such as creeks or ponds. Those things can really affect the development of limestone below it. To give you a little bit of background on how our limestone developed, we quarry from a vein of limestone from the Edwards Aquifer. And this is basically just tons of little caverns and this where the groundwater is below and it comes up through our limestone caverns. So that being said, we are actually quarrying at the very top vein of an Edwards Aquifer where the groundwater has subsided down past the limestone. So we've got a lot of really hard, dried out limestone, areas that have developed. That way we're not popping into groundwater and it's flooding the entire fields. So the further south in Texas you go, the more you get to where groundwater is closer to the surface in Edwards Aquifer, making that limestone not suitable for building materials. So now I'm going to kind of give you a fast forward to one of our older pits. This is a very fresh pit. This is a brand new one that we're just smoothing out and clearing out the land. The more prepared and the bigger area you prepare the land ahead of time, the better you are. It's a larger investment, but it's an easier way of adjusting and finding out what your fixed cost is for that land, because there are several steps in the production process, all of which are not the same with every piece of land. So calculating your true cost of your raw product is absolutely necessary, and having the land set up from day one is the most important process. So having everything cleared and ready to go on this huge piece of land is the most important. And to kind of put a dollar figure on it, on what it costs just to get the land ready to quarry before you ever even start cutting rock, this is about a $2 million expense. Now we're going to fast forward, which will take probably about 3 years to get down to this level. But this is what a quarry looks like once we get into multiple ledges. So you can see over here, give me 1 second here. So now you can see over here with my pointer that you're going to see the dirt level, like what I showed you before, only this was a much thicker level of what we call overburden. This is just dirt, and where the limestone, the water has subsided so much that the limestone never really got compressed. So there's a lot of little chunks of limestone, boulders on the ground, kind of a lot of nice looking stuff you'd like to see in a fish aquarium, but it's not nearly suitable at all for building stone. It would never hold together. Next rock down, you're going to see a block ledge, a ledge, and then this blue. All of this is useless limestone. It has not been compressed with time. It has all kinds of little seams and dry lines that are very loose. These blocks are usable, but not for building stone. This is what we would take over to a separate part of the quarry, and we would take it into a crusher. We would take it to a crusher to create road base. And in Texas, as fast as where our state is growing, as many people moving into it, we cannot create enough road base. Or if there's also this other really big use for this crushed aggregate is for burying Ethernet cables. It's an unbelievably high demand. As fast as we crush it, it's right back out the door, and it's made into our infrastructures. Now, once we get down to, so you got to consider when I mentioned there was a $2 million expense, that was just to get down to this ledge. Now we've got to go down through 4 or 5 ledges of stone, rough, irregular stone that takes a lot of time to remove just to get to usable building stone. And it's dawned on me, and I don't know how anybody ever figured this out, but who was the first guy that decided to spend that much money to figure out what was down below all that? Kudos to him, but he bit the bullet for all of us. At this ledge right here, this is going to be your first building stone ledge. As you see up over here in the top left corner, this is going to be our Montgomery gold. And I'm going to go over the block layout and how the sedimentary layer is set up. But if you see these irony gold textures, and then you see it like, for example, this white texture here, there's 2 parts to the block. There's the bed, and then there's the seam. The mineral seam, and I'll show you a diagram here of this in a minute, is going to be where you capture your color. This is a natural surface. It will split on the seam, and it will have irony and mineral deposits that give it its colorful characteristic. So at each one of these ledges, they look like stair steps. Every one of these stair steps is a different color limestone. The bed and the seam will have its own characteristics. And you can follow this for 50 to 100 miles away from here. And these stair steps will maintain nearly the exact same integrity if we go to quarry in a different part of the land. They may vary.
Yvonne, what part of Texas are you in?
We are just north of Austin, Texas. And that is the very furthest north point of the Edwards Aquifer. Most of the Edwards Aquifer is further down near San Antonio and west of San Antonio.
Thank you.
Yes, sir. And questions are encouraged, guys. The more questions you have, I think the more we'll all learn. So please feel free to interrupt me at any time. The next ledge down below that stair step is going to be our Blanco. Now, throughout this, to create our Blanco is created of multiple different ledges. And they're not all right in order with each other in these stair steps. So you'll see Blanco repeat itself 2 more times throughout the bottom of the quarry. And what we'll do is we accumulate those blocks and mix them together to create Blanco. The next one right below the Blanco would be our Blanco Antique. Blanco Antique is going to have a little bit of Blanco. It's also going to have a little bit of rhinestone in it. And what I want to show you here is you see the rhinestone. This is actually just a slab that's attached to the bottom of this block. And what it does is, these are true stair steps and hard lines, but they developed all in consecutive years. So a lot of times one ledge, it'll have a hard line between the two, but they will bleed into each other or they will melt into each other. Blanco Antique is a mixture of Blanco and rhinestone mixed together. It's where the two of them migrated. So we'll get, you get a nice hard slab, a very thin slab of rhinestone, which is only used for veneer, but it will swirl in to the Blanco Antique, giving it really pretty little sparkles, yellow movement, and it gives the block a lot of color. So you see there's a mixture of yellow and white in this block. As you go down below the rhinestone ledge, you're going to run to another Blanco ledge. Right below that Blanco ledge, you're running to your cream ledge. And it's the wildest thing because I have no clue what caused these hard stair steps and what time frames in history made that limestone completely compress and change to its very own color. But they're very consistent, as I said, within 100 miles of radius. It's just a wild thing the way geology did it for us. And we can pretty much count on that next ledge to be the right color, sometimes not the right density. So right below that cream ledge is going to be another ledge of Blanco. And then right below the Blanco ledge, which where you see this pile of dirt right here, the stair step right here, that's that Blanco ledge. And then this right here is going to be the surface that we're driving on, is the Picasso ledge. Reason that wasn't quarried up, typically build up a lot of that product because Picasso's popularity comes and goes. We're not really going to process something if we can save it for later when maybe that popularity comes back. One more thing I want to show everybody on this before we go on to the next slide and video is the way that we get to these stair steps. We have to cut a grid. Now, every ledge has a very particular size grid it has to be cut. And the reason being is not every ledge is the same density. So you have to cut the block at just the right size to where when we try to extract it, it doesn't crumble to pieces or cause a lot of cracking in it. So for example, your Blanco Antique ledge, you can cut a huge block so the grid is much smaller when you go through that. And if you go down to, for example, the Blanco ledge or the cream ledge, you see a much more narrow kind of little, more like rectangular ledges. And that's because we get much more usable material when we extract those blocks in smaller sizes. Does anybody have any questions about that? I'm going to move on to the next slide then. Here is a bird's eye view of us extracting, after we've cleared off that land, and that big land from the video we showed you initially. This is us extracting the first few ledges. And this is going to be a panoramic of all the equipment it takes to get that process going. I'm going to come back here at the beginning. I'm going to walk you through what you guys just visualized, and then we're going to break it down to each piece of equipment and what it does, or each of the main pieces of equipment. Okay, so back over here, we have the Vermeer saws who are cutting the grid. There's one hiding behind this machine here. These are this is block extraction, these two machines. One guy's popping blocks, one guy's unloading them and bringing them out to the staging area for all blocks. these pieces of equipment, these three, are cleaning up all of the waste that's created in block extraction, which as we go through this quarry, depending on, this is what we were talking about before, picking the right type of land. If you're picking the right type of land, there's a lot less of these guys needed to be around because you're getting a nice quality, solid, big, thick block. If blocks break as we extract them, they're almost useless for us to make building material out of. We need nice, big, consistent size blocks for the next several steps of the production process. And I'm going to keep on explaining that as we go through the rest of the production processes. But the more these guys are over here doing this, the less useful this land is. And I'll be quite honest with you, only having to have 3 pieces of equipment to clean up after all of this process, that's an extremely efficient production process. A lot of times, these guys are always a little bit further behind than what these guys are. So this was a very good piece of land to start quarrying. So we'll go on to the next slide here. This is a Vermeer saw. And this is the only saw that we have in all of our operation that doesn't have water running over the blade to keep it cool. These saws were actually made for cutting ice roads up in Alaska and Canada. And we ended up, they were not made to cut limestone. We found a use for them to do that. That blade that you're looking at right there is over 100 inches tall. And for the amount of space that it's going into the ground and then it's cutting over 24 inches of the ground. So it's cutting over 24 inches of the ground. Since this is the very first ledge and we're just drawing we're just drawing out the grid. See this little nut on a string hanging here. What you can't see, there's a red line that's been drawn. And what this gentleman will do is he sits up in here all day, and God only knows how hard his eyeballs are jiggling. I would not want to ride on this machine all day. But he has that little nut touch that line the entire way through. Because if he veers off 1 inch to the left or 1 inch to the right, by the end of a football field, that will ruin the entire first ledge just by that one little mistake. Now, this blade could go much further into the ground, but he's only cutting the first ledge, which is only 18 inches thick. So if he drops this blade into the ground 24 inches, he gives himself a guideline for his next grid on the next ledge below, and he thoroughly cuts through that first ledge, making it much easier to extract that block on its natural dry line, which is at 18 inches thick. Now, this slide is the one that I find the most interesting because you're going to see how unbelievably skilled these gentlemen are in this machine. If I had to do this, I would demolish every block that you ever put in front of me. They never make a single move with these tools. And you'll see as we go through this, how they move things around and flip these blocks upside down without damaging them and making it easy for both of them to work and make the extraction so fast and the yield so high. It's pretty amazing how good they are at it. And I'm going to play this video for a little while because it's interesting to watch. So now what he's doing right here is he's staging 2 blocks for the loader to be able to pick up both at once. This is a lot more efficient to pick 2 blocks up versus picking up just one. You can see here, he's just cleaning off the top of the block, tips it over, picks it up. Stacks on top of another one. Doesn't drop it. Now, from what you saw him do right there, removing all the small broken pieces, all these small broken pieces, these are not usable product. This is going to have to be turned into road base. So how good these 2 gentlemen are at getting solid, consistent blocks out of the ground comes down to, number 1, their workmanship with their equipment. Number 2, the quality of the rock that you're quarrying. So if you're able to scrape off just only 4 foot of overburden versus having to dynamite some ledges, if we were to dynamite ledges, all of this, a ton of this would be all crumbles until you got way, way down in the ground. But one of the reasons he's removing all these little pieces is that if that loader comes in and one of these pieces hits the side of his tire and pops it, you have to replace all 4 tires, not one, which is an investment of over $24,000. So he has to be removing area for that loader to come in without having to run over these rocks. And causing major expenses. Now you see how he just kind of stopped in the middle of that process, and you saw how the blocks split. They're not going to waste their time with extracting that piece. They're going to go all the way back down to the right, start at the other end, and work their way down. Because if that block split, most likely all those blocks in that row are going to split. That's a natural line. So they'll come in there with a loader later and not waste this excavator's time and scoop all the pieces up at that point, throw them into one of these big articulating trucks, and dump that over by the crusher. Any questions? Now down to a little bit of the buildup of our blocks. Okay, so here's the way the blocks are coming out. And we're looking at these both from a side angle. Limestone is a sedimentary stone. you're going to see these bed seams, these lines that go through it. This is what creates our real pretty movement. And sometimes these lines break and they have really pretty irony colors in them, like I showed you earlier. But this is how the sediments over time laid over and molded into this stone. So very important, the entire production process, these dry lines are how we use to create the color and how we make the product efficient with a very high yield. Sawing billets. This is the first step to creating a thin veneer product. And what we do with the billets is we're going to create billets to create a full bed stone. And when we lay this block off in a run, we're going to cut a slab. And right here, you're going to see a slab of 4, 6, 8, 10s, and 12s. This eventually, this 4-inch, this 6-inch, this 8-inch is going to be the face height of your veneer on the wall. Okay? And let me show you exactly how we create that real quick. And this is also, this next video is going to remind you when I mentioned before why we don't want small blocks. And I'll explain that during the video. Now notice right here how these blocks are all very, very close to the same size, and they're in a perfect line with each other. That's one thing I want you to focus on. It's from a production standpoint. This is how you get a very high yield off of your when you cut your slabs. That everything on this run is going to be the exact same size. Now we're going to stop you right here. See how they're all in a row? And you're going to see this little block right here that's out of shape. And you can imagine if I run this all through here to create a slab, I'm going to miss a bunch right here. The reason we put this block here, this is a catch block. We're going to cut a bunch of slabs out of this that are going to be your 4, 6, 8, 10, and 12-inch heights. Sometimes those slabs fall over. Well, this catch block will catch those slabs so they don't fall over and damage or create a domino effect along the entire line. So there's a catch block on the very end, and then also we'll put one on the other end as we go. And as you can see here, these are 4 and 6-inch slabs. You can see your 6 inches here. This is eventually going to be the face of your veneer. And here's your color seam that we mentioned. You know, you got a white seam. You can see the dry lines or the bed seams that we showed you in the drawing earlier. You can see the lines here. Those are naturally occurring in the rock. And we want to cut this block in this direction. And over here, what you're going to see stacks and stacks and stacks of what we call billets. We're going on to the next step in the production process, which is to the choppers. This is what creates our split face on our veneer. So this is all inventory for the next one, and we're going to stack it each individual one of these piles. They're all the same height of the same color stone. You got your 4s, you got your 4s, you got your 6s, you have 8s back over here. And these two guys, this guy's unloading all the saws, this guy's loading the ramp to the chopper. Billets. Each billet, what we're going to show you first, because the direction of the seams, we need to chop with these seams. So we flip the seams vertically, straight up and down. So when we hit them with the guillotine chopper, it will chop naturally with that seam. If we chop against the seam, you cause a different coloration of the stone. You also cause a lot more waste in the production process because it tends to burst and not chop very clean. So what we're going to do is we're going to take those long slabs, we're going to chop the lengths of our veneer first and then rotate 90 degrees. Let me show you what we're talking about here. And what they just did there is they loaded them up on there. And like I said before, we were going to chop perpendicular to the dry lines because the opening of this chopper is only 36 inches. And those slabs that were laid up there were around 50 to 60 inches long, depending upon the ledge. So there's no way to send them through the chopper without having to chop perpendicular to create your links of your veneer. So they send it all the way through, flip it, rotate it, bring it back. And the one thing I'm going to show you in one of the videos forward is that there's chopping those lengths by feel, but a very particular length. And that's to maximize the amount of stone you can fit on a 48 by 48 inch pallet. And that's what you just watched them do, was chopping these lengths. And we try to chop them at random, but also there's a method behind their madness. They're chopping a certain amount. So when the guys on the other end are loading them onto a pallet, that everything fits like a puzzle piece, which is pretty wild how they do that. And this is going to be chopping with the seam to create the split face. one thing I want to bring your attention to is to notice the teeth on this guillotine chopper. There's on the top and they're also on the bottom. But when they go through this rock, they only move about 2 inches. They do not go all the way through. So that's why you're going to see when you see full bed depth veneer being 3 to 5 inches thick, it's because you can't get a true consistent chop at 3 inches, 4 inches, or 6. When you hit it at about 4 inches, it's gonna travel. The crack has to travel. So 4, 6s, and 8s, that crack has to travel much less distance. When you get in those 10s and 12 inches, the crack has to travel nearly 8 inches and 36 inches long to get to the other end to create a good solid veneer. The reason I'm bringing this to your attention is you're going to wonder here in a little bit when we get to thin veneer why the guy's hammering the heck out of his stone. It's because it's such a big piece and the crack doesn't travel very clean. I'll explain a little bit more to that later. Now, as you see the way they're setting this on this pallet, you see now why the links were chopped where they were. They can fit exactly 2 pieces on this side and 1 on this. And as they go through this pallet, they're going to puzzle piece this thing together. That not this guy, but the 2 other guys the way back were working in conjunction to make this guy's life easier and to maximize what goes on with this pallet. Now, one thing I want to bring your guys' attention, these 2 gentlemen right here. Now, I don't know if these are 2 gentlemen that in the entire quarry, you wouldn't want to accidentally bump into him in a bar and knock his drink out of his hand or something like that. These guys are no joke. Each one of these pallets weighs 2 tons. These gentlemen per chopper will each build up 30 to 40 tons of stone every single day. And from 7 to 5. In addition to that, that's usable product. They will throw off an equivalent amount, if not more than that, into junk piles. That is in a bucket over here to their left. So these gentlemen every single day, 5 to 6 days a week, pick up and carry themselves and stack themselves 60 to 80 tons of rock. You can notice here too, I want to show you something that when we were talking about the seam lines, when we chop on the seam line, look at the variety and color that you get from these faces. Those bed lines, that's where you get your color range in your stone. Some stones like the Blanco block, all of them are pure white and they're beautiful. But this is going to be the Montgomery gold ledge, the one that I showed you back at the beginning that had a lot of irony surfaces to it. And you can see from all of these pallets, you can see every one of these because it was chopped with the seam, you get this color range. Now, if we chop against the seam, you just get little orange lines through it. Because this line right here, this irony color, it's only a millimeter thick. It's just super tiny. But when you split right on it, it gives it this really pretty color range and gives the stone a little bit more integrity. This gentleman over here is actually wrapping this pallet. It's a complete pallet with chicken wire. And that's usually the product that we use to wrap all of our stone in. You could find better products to use. But unfortunately, the best thing about chicken wire is versus a plastic is that you can quality check your product. You can see right through it. If you wrap something in plastic, you're trusting these gentlemen to quality check your stone for your house, which It's fine. They do it all day, every day, but they may not have seen the mock-up. So we need to be able to go over to inventory and to be able to quality check that rock and make sure everything matches identically the way it's supposed to for your job. And this is what the diagram looks like with the completed full bed veneer. So sedimentary layer is going this way across it. 12-inch lengths, 3.5 or 3 to 5 inches thick. Shoot, and this is going to be your height, your height, your height. And this is what it looks like. Now we're almost to thin veneer. This is what you could, this is actually also definitely a building stone. This is going to be the full bed depth veneer. And in certain markets, unlike California, where we don't have massive seismic activities and regulations, especially in the Texas market, this is the preferred veneer facade material. This is what the masons know. But I want to show you something too. You see this, the 4 inches. This is going to be 4s. This is going to be 6s. This is going to be 8s. And if you can see the thickness from the edge of these stones, nice and clean, a little bit off. But look when you come over to an 8-inch and look at how far that crack had to travel. You see how they arch and they bend and they bow. So whenever you guys are designing your projects and you say, you know, it seems like every customer that I ever deal with always wants a bigger and a larger piece than what you can actually make. Well, we can make bigger. We're not going to say it looks the best. You know, you would have unbelievable shadow lines if you were using your thin veneer with the kind of arch, the cupping and the concave and the convexness of these materials that you see here. So I'm going to show you on the next slide or next video, when you see that our thin veneer getting loaded, the guy is just hammering the heck out of the stone. He's trying to smooth this bulge out. He's trying to hit it from the side where the dry line's going through it. So it gives it a nice smooth surface to lay up against the conveyor for the thin veneer. So you get a good piece that's about 1.25 inches thick from one end to the next. Now, the reason that he split that piece in half and threw the other chunk over was because the bulge was entirely too big and bellied out to go through this without cutting the top and the bottom off of the veneer and making it only maybe 1/4 inch thick at the top and the bottom. We like to make our veneer very consistent from top to bottom, so you have a very consistent facade. So he split that in half and threw it over, because if you notice, he made a lot of hammer marks in the face. He needed to split it in half and hit it from the right or the left side to split the seam off to get rid of all those hammer marks. And he just couldn't do it with the full piece, so he's going to break it down and make a little bit of a shorter piece. Now, one thing I want y'all to notice is when it comes out the back side, you're getting two pieces. Right here, this smooth middle piece, you know, because you think full thickness veneer is 3 to 5 inches thick. We have to cut this down to two pieces that are 1.25 inches thick. So you're going to have some material in the middle that just isn't usable and is too thick. You have to have that material there to make sure you got room to make two good pieces. So you're going to see 3 pieces come off. This is from 2 pieces in a row. So you're going to get 2 pieces for every piece that comes off the back of the thin veneer. Now, as these go back onto the return conveyor, you're going to see this is a piece, that's an exchange, and you'll see him come over and he's going to throw it away into this waste bucket. At the end of this, you're going to get pieces that just won't be suitable to go back through another time and get a good piece of thin veneer out of it. And also, you're going to get that middle blank that's smooth on both sides. It's all going to go into this dump bucket. And this is going to be all usable product. And you can see from the thickness on the side, that's the minimum we'll let it go. But if I have those big bulges on the face of that veneer, all 4 edges would look thinner than this when I run it through the thin veneer machine without hammering that face off. We want this nice, consistent thickness from the top to the bottom. And that's why he was tooling those pieces so hard.
Hey, Vaughn, are you using diamond blades in the wet saw there?
Yes, sir, we are. Yes, we use diamond. We use industrial grade diamonds, which are black and they're crumbles. Mm-hmm. And we mix them into an epoxy that get put onto a segment of that blade.
Thank you.
And that's one of the reasons why we have to run so much water over it, because if those blades heat up, that would loosen up the epoxy that holds those diamonds in place and you start losing them. So limestone's great because limestone's nothing but calcium carbonate. I literally don't need to change those blades, but maybe once a year. But if I want to sharpen those blades, I will only take 1 pallet of a sandstone and run it through. And because sandstone has metal in it, it will heat the blade and the epoxy up to where it actually sharpens our blades. So once a month, we take a pallet of sandstone and run it on a limestone blade, and our limestone runs twice as fast for the next 3 weeks. I'm going to go through just a couple diagrams so you understood what we just saw. So this is the first run. Here's your thicker piece, and the split face is facing this wall right here. So again, if I had a big bulge on the face of it, it's going to push that whole piece back here to the left, only giving me a little bit of what basically poked out the furthest coming off of that. So you got to get this face, which is a split face, as flat as you can to get a nice long piece that's very consistent in thickness. This piece right here will go down the return conveyor, come back up and get sent through again, only facing where this 8 is, up against this wall that time. Here's your return. This is coming back the other way now. So this piece right here, this is the smooth piece that was facing the other side of that saw, coming back through. This side over here is the other split face that hasn't went through. So this piece, this piece, this piece, this piece, and this piece is all the blank. That's the waste product. And that will go out and that will be crushed into road base. We've also found some markets that they do like to save the blanks, and they use them they dry stack them facing up and down for landscaping, flower gardens. Basically everything we do from the time we tear up the ground to the time we make your veneer, every bit of waste is utilized in some way for building product or for road basing. And here kind of breaks everything down. Your full veneers, all three pieces from the beginning. You got a blue side, you got a green side. Those both have a split face on them. The red in the middle is your blank, your useless piece. This is the first run through. As we turn everything around and go back through, let's say the saw's over on this side, you run it back through, and this is how you get it the second time. And then you remove the blank from the back side of the saw. Now, we don't have a video of the corners being cut. I'm going to kind of walk you through the process. I'm going to add that to this presentation later. The corners are a little bit different. We can't cut them on that exact same saw. We need a saw that has two blades and they sit on a 45-degree angle. First off, to run them through there, because the opening of the machine is only 12 inches, we can't use those big, long pieces for thin veneer. We have to hammer them down to less than 12 inches. So you'll get your corners. This is going to be your split face, and this is going to be your split face. So what we're going to do is we're going to cut a piece right out of here to make this the L corner. And here's going to be your 45-degree angle. This is a belt. This is a belt. This is a big blade. This is the little blade. So we're going to cut your L right out of this piece right here. So now the thing with the corners though, because this runs on a 45-degree, if there's any bulges on both sides of this stone, it could really make that corner whopper jawed. So a lot of tooling needs to take place. And that 45-degree is of utmost importance, because if we try to stack this standing straight up and down, it will wobble as it gets sawn, and it will throw your L in the middle way off to where it'll just run angled through it. And then you really get some fussy masons when they got to go and back butter the piece and get them all leveled out. So we have to do a lot of tooling to get these to run through here real smooth, which is why your corners just cost more than your flats. Here's a breakdown of the piece. Full veneer to be cut. You lay it back down. This is their 45-degree right here. First cuts right through here off that big blade. Second cuts off this one. You can use this for blanks. Some folks, they want to save the money and they want to use it part of their flats, and you can run that one piece that's going to have a split face on this blank. You can run it back through thin veneer and they utilize it there if they so request. We allow customers to say, hey, do you want your corner blanks or do you not? And there's finished thin veneer. If you notice our packaging, this is all made, I don't know if anybody remembers when there was a massive wood shortage. Scared the life out of me because I like to use more wood and make my crates more sturdy than anybody does. So we use a ton of wood on our crates, so you can triple stack these crates, because in California, the amount of space you have there is just not a whole lot, on job sites or in distribution yards. So we need to be able to consolidate our product there and stack it as high as we can. So these are very, very durable crates. And that's kind of the rundown of our thin veneer. Now I have a whole nother half of this presentation, but unfortunately I've been gabbing on for almost an hour now. I don't think we have time to go over it. Jackie, are you wanting to wrap this up?
Yes. Are there any questions out there that we want to get to before we we go ahead and finish this seminar.
I have to say, what an awesome presentation. You did a great job, Vaughn.
Thank you very much.
Yeah, I just want to say thank you. I thought this was well done, and I'm glad we're recording this because we can share this with our customers on how-to stuff. So I thought this was well done. It's probably the best one I've seen yet. Excellent job, Vaughn.
Thank you so much.
So Vaughn, can you share with us what is the other part of the presentation? What's the subject matter? And
It is our American Modern collection, and you can find this on our website. The other part of this presentation, and if Graniterock wants to schedule another one of these, I'll be happy to give that presentation as well. But we created, unlike a lot of other quarries that have been in the ground, they went through 3 or 4 owners over the course of 30 years, and they're still selling the exact same products that they always have. I had the benefit before owning a quarry of living in Southern California and working side by side with some of the top architects and designers out there and help creating some of the modern trends that we do with our stones. So much so that we were able to create an entire collection of modern layouts and modern product lines. So that's a little bit more of like a product line evolution is what we created. So 5 new profiles to help specify for modern designs. So
very cool, very interesting. And Jackie, I'd certainly vote for another session to hear the American Modern collection.
Of course, I agree, Keith. So I can set something up with you, Vaughn, offline.
Great. Be happy to.
If there are any other questions out there? I think you were just that good, Vaughn.
Well, we tried. I know a lot about making big rocks and little rocks.
All right, then. Thank you all for joining us today. We appreciate your participation and hope it was of your liking. We also hope to see you all here Tuesday, November 1st to further expand your knowledge on Protector Wrap products. Same time as today, 10 a.m. to 11 a.m. Once again, I would like to thank Vaughn for taking time today to share his knowledge with us today. That concludes today's product knowledge seminar. Hope everyone has a great rest of your day. Thank you, everyone.